All right, so here we're going to combine probabilities. So there are a couple of types of probabilities. There's an and probability. So that means that two events are independent if the occurrence of one does not affect the other. So that's the probability of A and B, and you're going to multiply them. So, so the probability of A and B means we're going to have the probability of A times the probability, this would be for dependent events. So sorry, I was like, wait a minute. So this is independent. They don't affect each other. The and probability for dependent events means that two events are dependent if the outcome of one event affects the probability of the other. So that one is going to be the probability of A times the probability of B, given that A has occurred. So that'll be the intersection is equal to the probability of A times the probability of B given that A occurred. Right. Okay. Sorry, I was looking at it going, is that? Yes, that's right. All right, so then either or probability for non-overlapping events. So non-overlapping means that they don't overlap at all. If they cannot occur at the same time, so they don't overlap. If A and B are non-overlapping events, then the probability that either A or B occurs will be like the probability of A unioned with B. You'll add the two probabilities. So one of those events would be flipping a coin, heads or tails. They can't occur at the same time. They do not overlap. You get heads or you get tails. You can't get them at the same time on a coin. So you'll add the probability of this plus the probability of that. And then the either or probability for overlapping events, you'll have two events that actually overlap. And if they can occur together, so the probability of A or B will be the probability of A plus the probability of B, and then minus the probability of A and B. So it'll be the union of the two. You'll take the probability of A plus the probability of B and then subtract out the intersection, because otherwise they get counted twice. And we'll talk about that as we get to it. All right, so suppose you toss 3 fair coins. What is the probability of getting 3 tails? So let's go look at this. So this is 6.5, and we're looking at the probability of 3 tails. Well, the probability of getting 1 tail will be 1 out of 2, and a second tail will be 1 out of 2, and a third tail is still 1 out of 2, right? And we've talked before that when, because they're independent, we're going to multiply these. So if they're independent, we're going to multiply the probabilities. So 1/2 times 1/2 times 1/2. To multiply that out, you can use a calculator, but it'll be 1 and 2 times 2 times 2. When you're adding, you don't add the denominators, you just add the tops, right? But we are multiplying, so you multiply the top and then multiply the bottoms. 2 times 2 times 2 is 8, so that is your probability. All right, example 2. A 3-person jury must be selected at random from a pool of 12 people that has 6 men and 6 women. What is the probability of selecting an all-male jury? So we have 12 people, but 6 of them are men and 6 of them are women. So what's the probability of getting an all-male jury? All right, so this one's gonna change just slightly, right? So we're looking at the this will be example 1. This will be example 2. So the probability of getting 3 men. This is a dependent event. There's a thing called without replacement. So as I have the 12 people, as I pull the first one, the number of people left is going to go down. So if let's put up our coins here. I don't know exactly how many we have at this point. So 2, 4, 6, 8, 10. Oh, we still do have 12. I wasn't sure. So I have 12 coins here. And we will put them as, so 6 of them I have as heads and 6 of them have the tails. So we can look at this as like men and women, however you want to look at it. It doesn't matter what the objects are at this point. It's going to have the same concept. So if I pull out one of them, this is 1 out of 12, right? But when I go pull out the second one, I don't have 12 because I didn't put this one back. I chose this one. They're chosen. When I pull the next one, this will be 1 of them out of 11, right? Now, depending on what it is, if I was pulling, like, there's a chance of, let's say, we'll call them heads versus men and women. So if I get a head the first time, because I had 6 heads and 6 tails, this will be 6 out of the total of 12, right? If I pull another head, there were only 5 heads out of the total of 11. If I pull another one, then there is 4 out of the total of 10 possible. So it's going to decrease each time when they are dependent. The other thing that occurs on the previous one, we didn't do that because flipping a coin is independent. They're independent of each other. There's no, one doesn't depend on the other, so that's why those don't reduce, but these will. All right, so for the first opportunity, we have to draw the first juror. We are going to get a chance of getting a male juror 6 out of 12. Because I took out one of the guys, on the next chance I only have 5, and because I took out one of the people, I only have 11 left to draw from. And then for the third one, we are down to 4 guys out of a possible of 10 people. And then again, we're going to multiply this. 6 times 5 times 4 will get us 120. Out of 12 times 11 times 10 will get us 1,320. And this will become 0.091. All right. Okay, so that's the probability of getting the guy. All right, or getting an all-male jury. Next question. So a polling organization has a list of 1,000 people for a telephone survey. The pollsters know that 430 people out of the 1,000 are members of the Democratic Party. Assuming that a person cannot be called more than once, what is the probability that the first 2 people called will be members of the Democratic Party? All right, so these are dependent because you can't use them again. So if I pull the 1, I can't use that person again. So this is the same type of explanation as there was on the previous one. So we are looking at the probability of 2 Democrats, right? I'm going to put them as 2 Dems because I don't feel like writing out the whole word Democrats, and it's not very clear. Well, let's rewrite that. The probability of 2 Democrats. All right, so the first call that I make, if I get a Democrat, there were 433 out of 1,000. And then the second one would be 432 out of 999. Okay? Because it went down by one person and it went down by one Democrat. Now, when we do this, I'm not going to multiply across. The numbers are going to be really big. So I just put those two in the calculator, and I got 0.1872. All right? Now, let's look at this. That's because of the way that happened. Now, we could take note here. What would happen if we were to treat the two calls as independent events? Because a selected person is not removed from the list. Let's just say that happens. So in that case, so this was dependent, right? So this is dependent. Because given that this occurred, that changes that. What if we treated it as independent? If we treat it as an independent, we get 433 out of 1,000 times 433 out of 1,000. Let's say we don't put, we're not going to take the person off the list, and we happen to call them twice. This would get you 0.1875. This doesn't change very much, does it? The result is nearly identical to the one that we found here when correctly doing the calculation. In general, if relatively few items or people are selected from a large pool, like what this is happening, then the dependent events can be treated as independents with very little error. Now, you need to do it the right way, but do pay attention. You might get close to the number and think, oh, I'm good. Maybe she had a typo or something, or I'm just really close. You've got to be careful about the difference and paying attention whether it's a dependent, don't want to call that person more than once, or if it's independent and they're all put back in. All right, this is something that actually gets used at polling events, treating everybody as being independent when the sample size is small. So that's just a little bit of note of information. All right, example 4. Suppose you roll a single die. What is the probability of rolling either a 2 or a 3? So this is an OR statement. So the OR statement is going to put us into a different formula for what we're doing here. It's going to be the probability of A or B. So we're going to add the probabilities. These are non-overlapping. You can't get a 2 and 3 at the same time. This will be a non-overlapping. All right. So, for example 4, we're looking at the probability of a 2 or a 3 will be equal to the probability of a 2 plus the probability of a 3. All right, what's the probability of rolling a 2 on a 6-sided dice? Well, we've talked about this before. On a 6-sided dice, there's 6 sides. Getting a 2 is one possibility. So it'll be 1 out of 6. Rolling a 3 is also 1 out of 6. Well, they have the same denominator, so we're just going to add across. 1 plus 1 is 2 out of 6. This denominator stays the same. They both are even numbers. They'll reduce by 2, and we end up with 1 out of 3. So I divided 2 by 2 and 6 by 2. So the chance of rolling either a 2 or a 3 is going to be 1/3. All right, example 5. To improve tourism between France and the United States, the two governments form a committee consisting of 20 people. We have 2 American men, 4 French men, 6 American women, and 8 French women. If you meet one of these people at random, what is the probability that a person will be either a woman or a French person? All right, so for this one, we're going to create a Venn diagram to look at. As far as the men and women, there's 2 American men and 6 American women, there's 4 French men and 8 French women. And we want to know about the probability of getting a French woman, be either a woman or a French. All right, so this one's going to have some overlapping events because they can be French or they can be a woman. So they could be both, right? So this one's going to have some overlapping, and so we're going to have something more like this. So the union of French and women will take the French and the women, and then we got to subtract out where they overlap. So a picture is sometimes worth 1,000 words. So here we have in the blue circle, it's all the French, and in this part with the dark blue and the women, this is all women. Okay, so these are French women, these are American women, and then these are French women and French men. And then out here we have the 2 American men. All right, so we're missing a line there. Looks like it didn't come out very dark. Alrighty, so let's go write out what we've got here. So we can kind of see what's going on. We have the probability of trying to find French or women. So the probability of a French or a woman. Well, the probability of French, the total number of French people is going to be right? Yeah. So the total number of French is 4 plus 8, so that's 12. Now we can see where they overlap here, and that's where we have to have the intersection where we're going to need that here in a minute. But first we need the total of French. So this will be the probability of French plus the probability of women minus the probability of the French intersected with the women. Okay? That's going to be that formula. And this would be the probability of F unioned with W. So that's a union. This will be the intersection. All right, so French, there are 12 French people out of the total of 20. So this will be equal to 12 out of 20 plus the number of women. For women, we have 8 plus 6 is 14 out of 20. But we have to take into account those that were French women. So we have to take out the 8 because we've included all the French, we've included all the women, but we've counted the 8 twice because they counted in the French category and the women category. So there are 8 French women, so we need to subtract that. All right, so on the bottom we're still left out with the 20, but if we add this we get 12 plus 14 will get us 26, minus 8 will get us 18 out of 20. So and that's where this comes kind of in handy as far as a visual. These are all the French, these are all the women, but these 8 French women are where they overlap, so you have to take those out because you can't have them count twice. And if we look at our picture, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 that are French or women, and there's only 2 people that don't count French or women, and that's the 2 Americans. So logically, we can also make sense out of that. But we can use the formula to figure out the math for that. All right, our last question. Oh, and that was example 5. This is example 6. All right, does this make sense? Or, interesting. Does not make sense is what I have typed. It should be does it make sense? Typo that. The probability of you winning your state's lottery this week is not affected by whether you won that same lottery last week. Does it make sense? The probability that you won it last or this week does not affect whether or not you won it or you won the lottery last week. Well, that makes sense. There are two independent events. If you bought a lottery ticket and you win last week, those tickets are all gone, right? And then if you buy a ticket this week, that has nothing to do with this. They are completely independent events, so it makes sense that this week's outcome will not be affected by last week's. So it makes sense because they are independent. So results are independent. So that means what happened last time will not affect what happens in the future. All right, so that is the end of chapter 6.5, and well, section 6.5 and chapter 6. So woohoo. So let's talk about a couple of things here. You need to do your homework. And now you have an activity. This is the first one of chapter 6. I kind of put them all together. You're going to answer some questions about how many different outcomes can occur. So flipping a coin, there's like 2 outcomes. Rolling a single 12-sided dice, there's going to be 12 outcomes. Here you're going to draw a tree diagram showing how to flip. 2 coins can be flipped. So you got to start, when you're doing that, you want to do a begin. Let me just give you a clue, so if you really watch the video, you'll have a clue how to do it. So you'll have a begin, and then you're going to flip it. You get heads or tails, and then off of each of those flips, you get heads or tails. Okay? And then from that, you're going to list all of the possible outcomes. So did you get to like head, head, tail, tail, head, tail, that kind of thing. That's what the outcomes. Then you're going to answer some questions about a deck of cards. I did this so that we can make sure you understand. So how many cards are in the deck? That was in the lesson that we did. And there's also stuff in the handout. How many suits are in the deck? Which ones, what are the names of the suits? Which ones are red? Which ones are black? And how many cards are in each suit in a deck of cards? And then on the back, how many ways or outcomes can 4 dice be rolled? So you got to know how to do that. And then you're going to do some probabilities of drawing a 6. And here is one of these types. You're going to find A union B, given the probability of A, of B, and the intersection. That's a similar problem that we just did. Okay? And then what is the probability that something will break, given that it had a warranty? If you have questions on those, make sure you ask. And then a little hint, remember all the probabilities of any event total equals 1. All right, now you also have another project to do. This will be in your D2L. It's the project for probability in Statcrunch. So you're going to go into your Statcrunch and you're going to do some different things. So here's some instructions on what to do and how to do it. And then you're going to fill in the table through the apps in there. And I've got things listed out pretty straightforward. You open the Statcrunch, click on Applets, go to Games, and then Fair Dice. And then you'll get into that. And then you're going to answer some questions on that. So that is your next Statcrunch project. So make sure you're doing your homework. Make sure you're submitting all of your activities. And then make sure that you are not getting behind at all. because that's not going to help you. Getting all those projects done would be a good thing. And study for your exams.